Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to learn how to calculate the arc length of a circle. So let's go ahead and get started. So, when you are dealing with a circle, there's different parts of a circle that, make up what a circle is. So, whoops, sorry about that. Start with this, there we go. Beautiful. Oh, that's too thin. Okay, there we go. Nice and beautiful. All right. So when you're working with a circle, there are several pieces of information on it, obviously. So of course you're going to have a radius. We're going to call this right here R. And then of course if you have a terminal side and an initial side, you're going to have a theta as well. To give you an example, so something like this. Or you're going to have an angle, and this angle is captured here as, again, we're always going counterclockwise, as theta. Now, from the initial side until the terminal side, this space right here, going right across here, this is your arc length, often called S. And there is a way to calculate this distance here by just knowing a very basic formula. If you want to calculate the arc length here, you need to do the length, or S is going to be equal to the radius times theta. Now, one thing you should be noticing is that radius is in one type of units and theta is in degrees. There's going to probably be a problem here. So usually you have to convert everything to radians first. So there are two steps. First you convert to radians, then you use our little equation here. And so we're going to go through one example of this so you can see how this is done. So let's move on. So let me go back here. All right, so let's say I have the following circle, like so. All right, and we have, we have here, the following angles. The angle is 215 degrees. The radius is 10. So I'm going to try to draw this to scale. It's a lot harder than it looks. Let me see. Maybe I should use this. All right. Okay, that's at least a straight line. Okay. So again, this is not drawn to scale. Don't want to touch that. So, something like this, as you can see here. So the radius, our R, wait a minute, there we go. Our R here is going to be equal to 10. And the distance, the angle here, from there to there, is going to be 250 degrees. Oh, that should be a 10. 10. So we want to find the length of this guy right here, starting from this initial all the way over until we get to the terminal side. And it's not 250. Boy, this is a bad day for me. It's 215. There we go. And this is 10. And then this distance from here to here is going to be what we're trying to calculate. This is our S. So here's what we got to do first. First, we're going to convert our degrees, 215 degrees, to radians. And then once that's set up, we can finish out what we want to do here. So we got 215 degrees, and we're going to times that by pi over 180. This is standard for converting from degrees to radians. We've discussed this in a prior video. So I just multiply straight across, so I end up with 215 pi over 180, and that simplifies to 43 pi over 36. Not that deep. Now, remember what our equation is for calculating the arc length. It's going to be S equals radius times theta. Our radius times, degrees or radians. So now, this is what we have. We know that the radius is 10. There's nothing new there. That's basic information. So we're going to put 10. That's our R, if you will. And then we know our theta is going to be 43 pi over 36, like so. And so again, you just multiply straight across. It's like 10 over 1, if you will. And you get 430 pi over 36. And when you simplify this as much as possible, you get 215 pi over 18. That's it. So essentially, we kind of cut this in half by dividing by 2. And that's about as far as it goes. Now, if you really have to have an absolute number, it's going to be about 37. And we can confirm this. Whoops. If you just look right here, bring in the calculator. And so 215, let's see here, pi, and press equal, 67.5, 675 divided by 18. You can see 37.52 is the technical 37.524578918, if you will, if you really want to know. So there you have it. That is your answer for how to calculate this. So now we know that S equals 37. So the distance, in other words, the distance from this point right here until you get all the way over to this other side right here is about 37.5 units. That's what we learned here. So let me go back and summarize what we talked about today, and we'll conclude this video. So we talked about in this video how to calculate the arc length. And the arc length is that distance on the circle from the initial side to the terminal side when you're looking at an angle. And so to calculate this, you take to calculate the length of the arc here, you take the radius times theta, and generally we convert theta to radians. Oops. So in this example right here, the first thing we did was that we had our angle of 215 degrees. We had to convert that to radians. So we just did 215 times pi over 180. And so then, when we simplified it, we got 43 pi, and we then multiplied that by 10, because 10 was the radius of this particular circle in this example here. And so we got 430 pi over 36. You simplify that to 215 over 8. And if you calculate it, in a calculator, divide it, you'll get about 37.5. And so this is kind of how you address that. So I hope this video was useful for you and you were able to understand what we were talking about here. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.